Welcome back to Huawei Routing and Switching Elite Training for HCIE. Today topic we are going to discuss on route import and control. Let's start our part 7.
Alright, so the next one we are going to look into using the route policy to optimize the route. Now this is a very important example. Alright, so let's concentrate on this lab. Company A need to optimize the network and have these two requirements. The first requirement here, enable R4 to access 172.16.0.24 through the optimum route. Now what I mean over here is when this route is being sent to R2 and R2 import into OSPF. Now when you import into OSPF, the OASE preference here is 150. Now remember that we did the import from OSPF into RIP, and when we import this route into RIP, the preference will be 100. Okay, and when R4 sent to R5, R5 will send to R3 and vice versa. Now the problem over here is assuming that now R5 received the route from R3 and R5 send this route to R4. Now R4 have a decision to make. If I want to go to 172.16.0.0, I have two choices. I can go to R2 or I can go to R5. So which is the right choice for me? Now R2 is running on OSPF. R5 is running on RIP. But this is an external. Okay, that is a type 5. And since this is a type 5, we have a preference of 150 and RIP is 100. So end of the day, R4 will go for R5, R3, then to R2. So this will be a suboptimum route. Now let's look into the effect now. So if I jump back into my routers and I'm going to do a testing on R4. So if I'm going to do a trace to 172.16.0.1, so I'm here, I'm pinging to here. Now by right, this one will be the optimum path, so from R4 to R2 to R1. But when I do a trace, you notice that it goes into router 5, then router 3, then router 2, and finally reach the destination. So that is our problem here, because now we have a suboptimum path. Now for us to solve it, alright, so we have to do some route policy. Okay, so this is the command on how we can solve the entire solution. Alright, so firstly, when we do the import on R2, we are going to give them a tag. So for this example, we are going to use a tag of 10. So when 172.16.0.0 are being imported, I'm going to do a tag of 10. Now on both R3 and R4, we are going to configure the route policy. Let's look into the route policy here, and this route policy is called ASE preference permit node 10. I'm going to mesh based on the tag of 10, so which is being pre-tagged by R2. If I see a tag of 10, I'm going to change the preference of 80. So now I have an 80 here that representing 172.16.0.0 and 20, remember? So I have a preference of 80 versus here I have a preference of 150. So R4 will actually sending to the right path. Now same go for the R3 as well. So R3 may also be affected by the loop. So we are going to do the same thing on both R3 and R4. Right, so let's look into the solution in our lab. Okay, so let's jump back into our lab here. Firstly, on R2, okay, let me show you here, display CCOSPF. When we did the import, we never have any tag, but this time we are going to configure the tag. So let's go into the OSPF and I do an import static with a tag of 10. Okay, so that will be on R2. So in R4, so if I do a display IP route, which is 172.16.0.0, followed by the verbose. You can see that now I have a tag. Okay, and those with the tag, I'm going to change the preference to 80. So firstly, I'm going to create a route policy. And I'm going to call it ASE pref permit node 10. Okay, I'm going to match for a tag of 10. If I do match it, I'm going to set the preference to 80. Anything that is lower than RIP will do. Okay, so RIP is 100. Okay, and the OSE is 150. So I apply preference of 80, and anything else I will not be allowed. So I say that route policy ASE pref deny node 20. Okay, right. Next, I'm going to configure so that the preference will take effect. So what I need to do is go back to my OSPF. I'm going to use preference. Alright, so as you can see that there is the ASE, which is stand for AS external links state. So ASE route policy, ASE pref, and the default ASE pref is 150. So which means that anything that is inside the route map, or in this case the route policy, will be a 80, and anything outside will be 150. Okay, let's do a display route policy. Okay, as you can see from here, I do have two matches already, and I'm going to do this on the R3 as well. Alright, so for me to do that, let me do a trace here first. Okay, 172.16.0.1. So you can see that now it go to the right way. Okay, so it go into the correct way and not the other suboptimum path. But R3 may still have the problem, so I need to do the same thing here. So firstly, route policy ASE pref permit node 10. If I match a tag of 10, I'm going to apply a preference of 80. Anything else will be denied. Okay, so I'm going to deny this with a node of 20. I'm going to apply this into my OSPF preference ASE route policy ASE default 150. Okay, so display route policy. Okay, so that will be my route policy. So when I do a trace to 172.16.0.1, again it will go into the optimum path. So that will be on our first requirement. Next, we are going to move on to the second requirement. Okay, so let's look into the second requirement here. So the second requirement is to prevent routing loop when network environment changes. So in this example, so assuming that R2 are importing route into OSPF as an OSE. So due to certain reason, this network that is being sent disappear, and R4 still sending this to R5, and R5 still sending the RIP route to R3, and R3 importing the route from RIP back into the OSPF. Now, even though the network already no longer available, R3 and R4 are doing a mutual importing. So there will be a possibility of a temporary loop that happen. So let's look into how to solve this temporary loop. Alright, so in our example over here, we are going to use what we call the apply tagging and deny tagging. Now first, we have to derive the schedule on what are the tag to apply and the what are the tag to deny. So let's draw the table here. So firstly, we have the OSPF to RIP. Okay, and we also have RIP to OSPF. Alright, so we have two routers here, R3 and R4. R3 and R4. And both of these we have the apply and we also have a deny tag. Now let's look into how we can solve this puzzle. Now firstly, when we do the OSPF to RIP importing the route, now we are going to apply a tag of 100. Okay, so anything that I import from the OSPF using R4 will have a tag of 100. This tag will be carried to R5 and R5 is going to send to R3. Now when R3 detected that this is 100, so let me do from here. So I have a 100 that is being applied in R4 just now. Okay, when I do the importing from OSPF to RIP, that's on R4. So what R3 need to do is to deny 100, alright, from going back into OSPF. Clear? Okay, so that will be a tag of 100. So now, assuming that now we are going to do another one. So let's do the applying the tag from RIP to OSPF from R3. Okay, so RIP into the OSPF, I'm going to use a 200. Alright, in R3. So as you can see that I'm applying a 200. Now when this route are sent to R2 and R2 sent to R4, assuming that R4 when they send from OSPF back to RIP, I'm going to do a deny. Okay, so in the R4 OSPF to RIP, I'm going to deny. So first is RIP to OSPF on R3. I'm going to do a R3 RIP to OSPF. I'm going to apply, and there's the apply here. And when the OSPF back into RIP on R4, I'm going to deny. Okay, that is on the tag of 200. Alright, so that is only for both the OSPF and RIP into OSPF. Okay, and what happened on the other way? Alright, so now we are going to do the RIP to OSPF in router 4, RIP to the OSPF in the router 4. As you can see from here, we are going to use a 300. Okay, so RIP to OSPF, router 4, we are going to use a 300. So when OSPF back into RIP in router 3, OSPF back into the RIP in router 3, we have to deny the 300 tag. Okay, and the final one, if let's say we are going to do a OSPF to RIP, here we are using 400. Okay, so we are going to apply 400 and RIP back into OSPF into router 4, we are going to deny the 400. Alright, so in your exam, what you need to do is to create this type of table in your blank sheet of paper, and we are going to do this in the router. As you can see from here, this is on the router number 4. So this is the router 4 and the router 4. Now as you can see from here, the router 4, we are going to apply 100. So you can see route policy, OSPF RIP, permit 20, we apply the 100. Okay, and here we actually deny 200. So route policy OSPF to RIP deny node 10 if match a tag of 200. And at the same time, on the router 4, we apply the 300 for RIP to OSPF. So on RIP to OSPF, we apply a tag of 300, and for RIP to OSPF, we are going to deny a tag if it's 400. So this table becomes very important for you to configure your router in the right manners. So let's look into our configuration now.
Thanks for watching. Please do not forget to subscribe to our channel.